Okay, let's look at example 5 in our lesson 4-4. This is an application problem, finding a rate. Leah drives her car to the mechanic and then she takes the commuter train back to her neighborhood. The average speed for the 10-mile trip, oh, that's the distance, is 15 miles per hour, that's the rate, faster on the train. Find an expression for Leah's total travel time. If she drove 30 miles per hour, how long did this take? So, first of all, we want to write the expressions, right? So we can look at two different distances and the speed. So remember, your distance equation is equal to distance equal to rate times time, right? So time is going to be distance divided by rate. So we want to figure out how long, which is time. We want to figure out how long for the travel time for Leah. So first, car. If we say the speed of the car is r, the speed of the train is 15 miles per hour faster. So this is this is just an addition to the speed we have right now. We have for a car, and miles per hour is the unit, and the speed for the car is also miles per hour. The speed for the train is also miles per hour, so you just have to add 15. And then time is going to be distance divided by rate, and distance is the same, right? 10 divided by r for that one, 10 divided by r plus 15. So the total should be this expression plus this expression. So r plus 10 over r plus 10 over r plus 15. And we know how to add the rational expressions. So find the LCM and then multiply the numerator with the factor that you have to multiply by, and then and then simplify, and you can figure the answer out by plugging in 30 miles per hour. If this is 30 miles per hour, where are you plugging into? R, that is the rate. So when rate is 30, you multiply by 20 plus 150 divided by 20 times 20 plus 15. You don't have to add the rational numbers. You can just plug it in to R in the first equation, in the first expression here, and then figure it out as well. This is just another way, right? But of course, this may be a quicker way, but of course, we are practicing how to add and subtract rational expressions, so might as well practice, okay? So this is a word problem where we might want to use adding and subtracting rational expressions. So at the end, you will probably get 5 over 9 hours, or it could be about 33 minutes. So the total time for Leah is 33 minutes. Super quick. I guess it was a really short distance, right? 10 miles. It's not too far by car and train, right? Let's look at try number 5. On the way to work, Juan carpools with a fellow coworker, then takes the city bus back home in the evening. So it's a very similar situation. The average speed of the 20-mile trip is 5 miles per hour faster in the carpool. Write an expression that represents Juan's total travel time. So write the expression just like we did. You don't have to solve this, and simplify, okay? We're going to check both. Write the expression, the first the expression, and then the simplified one. So pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? So remember, our distance equation is d equals rt, and so the first equation for carpool would be 20 equals r plus 5 times t, and then for the city bus, it would be 20 equals r times t, right? And then the total time would be 20 over r plus 5, because time would be distance divided by r, plus 20 over r, and then you simplify this. So this would be the first expression that you could set up, but let's simplify. We can find the LCM, which is r times r plus 5. And then we multiply r with 20, and we have 20r, and then we multiply r plus 5 by 20. So using distributive property, we have 20r plus 100. And that's equal to 40r plus 100 over r times r plus 5. And that's really equal to 20 times 2r plus 5 all over r times r plus 5. So that's the simplified expression. Okay, so yeah, here we go. So 20 over r plus 5 plus 20r over r, or 20 times 2r plus 5 all over r times r plus 5 would be our final answer. Let's look at example 6. Simplify a compound fraction. A compound fraction is in the form of a fraction and has one or more fractions in the numerator and or the denominator. How can you write a simpler form of a compound fraction? So a compound fraction, for example, you could have all numerical compound fraction as well, like 1 over 2 over 1 over 3 plus 4 over 5. This is also a compound fraction. So if we have rational expressions with the compound fraction, it may involve multiplying, dividing, or adding and subtracting. So first of all, method 1, find the least common multiple of the fractions in the numerator and the denominator, and then multiply them. Multiply the numerator and the denominator by the LCM, or you can express the numerator and denominator as single fractions, and then multiply the numerator by the reciprocal of the denominator. So like you can work on the numerator first, and then you divide it by 1 over y, which is a multiplication of y over 1. I think you're more used to method 2. And then, but whatever method you use, you can simplify and figure out the same solution. And make sure your domain is whatever you have for the denominator that you have for the fraction. So yeah, so even in the even if the fraction is in the numerator, the fraction cannot still have a 0 in the denominator. So this still counts as a restriction in the domain. So your x cannot be -1, x cannot be 0, and then y cannot be 0 either. So check all the denominators before you perform any operations, okay? And that's going to be the restrictions in your domain or range or any other variables. Okay, so let's look at try number 6. Simplify each compound fraction for parts A and B. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Yeah, let's look at 6a. We have 1 over x minus 1, all divided by x plus 1 over 3 plus 4 over x minus 1. And so really, this is 1 over x minus 1 divided by this, right? But let's find the LCM. 3 times x minus 3, right? So we're going to multiply x plus 1 times x minus 1 in the numerator here, plus 4 times 3. And then we have the LCM of 3 times x minus 1. And then we want to make this into multiplication, and also we want to simplify this fraction. So we have 1 over x minus 1 times 3x minus 3, or actually let's keep it as 3 times x minus 1. In case we can simplify, right? And then multiply this out, x squared minus 1 plus 12, and then simplify. Oh, before you simplify, you can also cross this out, right? And then you have 3 over x squared plus 11. And that's it. You can't simplify any further. So That's our final solution for part A. Let's look at part B. 2 minus 1 over x divided by x squared plus 2 over x. And so this one, you have to rationalize the denominator for both numerator and the denominator. So let's first look at the numerator for this complex fraction. So the denominator here is 1, and the LCM would just be x, right? So you multiply x with 2 to make a fraction. So 2x minus 1 over x would be the first numerator. Then you're dividing that by the LCM for the denominator here is x, because this is x over 1, right? So you multiply x by x, you get x squared plus 2 all over x. And then you're going to simplify 2x minus 1 over x times x over x squared plus 2. And then you can cross this out, cancel them, and then you can't really factor them out, or simplify any further. So this would be our final answer, 2x minus 1 all over x squared plus 2. Okay, that was example 6, tried 6. Let's summarize our lesson. So finding sums and differences of rational expressions are not too hard if you remember the rules for adding and subtracting fractions for numbers, right? And for complex numbers as well. So remember that you first have to figure out the LCM or LCD, like the textbook says. The least common denominator. So the LCM in the denominator is LCD. And then you can add and subtract the fractions, and you can simplify them with like terms or canceling out the factors. Okay, so that was lesson 4-4, adding and subtracting rational expressions. Let's continue with the next lesson in the next video. Bye.